Good morning to Dr. Abdullah Atik bin Arifin and all my classmates. Today I would like to conduct an experiment which is called Severity of Quenching through the simulation. Objective: to study the hardness of medium carbon steel samples and their microstructures under the following conditions: as received, annealed, caramelized, water quenched, ice quenched, oil quenched. Apparatus used: 6 medium carbon steel samples, furnace at 910 Celsius, tongs, Rockwell hardness testing equipment, beakers, oil and ice quenching mediums, optical microscope, polishing machine with abrasives, bell grinder, abrasive paper, flat glass plate with wooden framework, electric hot air blower, cotton, metal reagent, etchant, Rockwell hardness testing machine. Aesthetic temperature: it is temperature at which aesthetic reaction occurs in phase diagram. Eutectic reaction: liquid alpha plus beta. Here, alpha and beta are phases of a binary alloy composed of A and B, where alpha is rich in A and beta is rich in B. Quenching: in material science, quenching is the rapid cooling of a workpiece in a quiescent to obtain specific material properties. This is a type of heat treatment which prevents undesired low-temperature processes, such as phase transformation, from occurring due to extremely high rates of cooling. Martensite: a hard and very brittle solid solution of carbon in iron that forms the main constituent of hardened steel is called martensite. Its microstructure is usually needle-like, thus depicting its brittle nature. Step 1. Obtain 6 identical samples of medium carbon steel and keep one sample aside as the control sample. Keep control sample aside and other 5 samples are annealing, normalizing, water quenching, ice quenching, oil quenching. Step 2. Austenize all 5 samples for 30 minutes at 900 Celsius. Turn on the furnace switch. Set the furnace temperature to 910 Celsius. Place all the samples into the furnace. Close the door of the furnace. Wait for 30 minutes. Turn off the furnace. Step 3. Remove the samples from the furnace and quench them in different mediums. Open the door of the furnace. Take one of the samples and put into the oil. Take one of the samples and put into the water. Take one of the samples and put into the brine. Take one of the samples and put the sample at room temperature. Let the last sample cool in the furnace till 400 Celsius. Let it cool until 400 Celsius. Open the door and take the sample, then put at the room temperature. Once all samples are cooled to room temperature, Each sample is polished and microstructure is observed under a microscope as shown in the subsequent steps. Why is the sample alternatized for 30 minutes? It's uniform austenitization. Step 4. Obtain a flat surface on the specimens by belt grinding. Step 5. Support a polished paper of 1/0 fineness on a flat glass plate. Polish the specimens, rubbing in forward direction only. Move the next fine paper 2/0 and 3/0 once the scratches on the specimen are uniform. While changing from one paper to another, the specimens and your hands should be clean, free from the abrasive of the previous paper, and the specimen turned through 90 degrees so that the stretch from the previous paper are at right angles and to the scratch for the next paper. Step 6. Finish polishing the specimen on 4/0 abrasive paper. Wash hands and specimens. Step 7. Do the fine polishing on the disc polishing unit. After fine polishing, clean off the polished surface of the specimens with water and dry it with an electric hot air blower. Step 8. Etch the specimens with 2% nitrile reagent by swabbing for a few seconds. Wash and dry. Nitrile reagent. Nitrile is the name given to an oxidizing etchant solution composed of aqueous, nitric acid, and ethanol. Step 9. Examine the specimens under the microscope and observe the structural phases. This is an sample. You can zoom into the sample into 100 times, and when you click the arrow, you can zoom in 500 times. Second, this is normalized sample. You can zoom into the sample into 100 times, and when you click the arrow, you can zoom in 500 times, and this is sample look like. This is ice quench sample. You can zoom into the sample into 100 times, and when you click the arrow, you can zoom in 500 times. 4. This is oil quenched sample. You can zoom in until 100 times, and this is sample look like, and when you click the arrow, you can zoom in until 500 times. The lastly, water quench sample. You can zoom into sample until 100 times, and this sample look like, and when you click the arrow, you can zoom in until 500 times, and this is sample look like. Which medium give the most severe quench? Is ice brine. Step 10. After noting the microstructural features of the samples, perform the Rockwell hardness test using the cone indenter for all 6 samples. Step 11. The hand wheel is turned until the specimen is in contact with the indenter and the pointer of the smaller dial gauge reaches the red dot so that minor load of 10 kg is applied. Minor load of 10 kg is applied. Step 12. The major load is set and the motor is switched on. The hand lever is kept in load position for 15 seconds. The reading is noted down using C scale. Click on the hand lever at 50 seconds to unload. Step 13. Values are noted for all the 6 specimens. This is the value of all samples. For sample 1, the value you get for RHN is 15. For sample 2, the value you got for RHN is 37. So for sample 3, the value you got for Rockwell hardness number is 41. For sample 4, the value you got for Rockwell hardness number is 60. For sample 5, the value you got for Rockwell hardness number is 55. And the last, the value you got for Rockwell hardness number is 51. The highest Rowell hardness number is 60 and it is for ice quenched. That's all from me. Thank you.